in these differentiation from first principles questions, it's really important to show every step of working out really clearly, because we know the derivative of sine x is cos x, but we have to prove it from first principles, showing every step of working out. So fx equals sine x. I find it helpful before substituting into the formula to work out what f of x plus h is first. So that would be written like this, and then in order to simplify that, we need to use the addition formula to get rid of the brackets here. So that would be sine x cos h plus cos x sine h. Now I've done that, I would look in the formula book, because the formula for first principles is in the formula book, and it is f dash x equals the limit as h goes to 0 of fx plus h minus fx all over h. So fx is here, so that goes there. Fx plus h we've just done here, and so that is going to go in there, and h is going to stay exactly as it is. But write it out really carefully, really clearly, showing each step of your working out. Okay, now if you look at where we need to end up, we need to end up here with a sine x here and a cos x here. So if we write this with a sine x here and a cos x over here, we need to work out what's going to go here and what's going to go here. Well, you can see, let's pretend we're not given this, because often you're not. Often you are just told to differentiate sine x from first principles. So let's ignore this for now, and just think, what would we have to do if we didn't know that? Well, sine x is here and sine x is here, so we would have a cos h left over. We've also got a sine x over here, so that would give us a minus 1, and it's all being divided by h. Okay, so you can see that if we multiplied this out, this times this will give us this, and this times this would give us a sine x at the end, and it would all be divided by h. If we do a similar thing for cos, so we've got a cos here, we've got a cos here. The only thing that we're multiplying cos by is that sine h. So we're going to have a sine h over h here. Okay, so we have now done the first bit. Should really put a bracket around the whole thing, since that's what it looks like in the question. But we've done part A now. In part B, there's not a lot to do really, except explain what happens as h goes to 0. Now, I think I would just tidy everything up a little bit before explaining about that. So as I was saying, in part B, we just need to decide what happens as h goes to 0. As h goes to 0, cos h minus 1 over h will tend to 0. Now, if you didn't know that, then there's lots of ways of showing this. One way is to just substitute a very small value of h into the whole expression. So 0.000 something, 0.0001 for example. Make sure you're in radians, and you should get an answer very close to 0. Later on, I'll explain using the small angle approximation why this is true, that this will tend towards 0. In a similar way, as h goes towards 0, sine h over h, that will tend towards 1 as h tends towards 0. So that will give us f dashed x, going back to this equation now, going back to here, we will get 0 times by sine x plus 1 times by cos x. So this is all going to disappear, which will leave us with f dashed x equals cos x. I think that would be enough to get the 2 marks, but you might be interested to understand why does this tend towards 0 and as h tends towards 0, and why does this tend towards 1 as h tends towards 0. I think the easiest way of explaining that is to look at the small angle approximations. So if I just get rid of this, so that was the answer. We finished the question, but just looking at in a bit more depth as to why this is true and this is true. If we look at the small angle approximations, explanations, when h is small, this is given in the formula book. You're told that sine h approximately equals h, and for that reason, that means sine h over h approximately equals h over h, which will obviously tend towards 1. H divided by h is well, it is going to be 1, isn't it? So that explains this one here. The other one's not quite so simple, but it follows the same principles. If you look at the small angle approximations, when h is small, cos h will approximately equal 1 minus h squared over 2. Now if we substitute all of this instead of this cos h here, that will give us 1 minus h squared over 2, all minus 1, because we've got to include this minus 1 here, and all of that is over h. So this, if we just simplify that for a minute, so we're approximating all of this by that, and if we simplify this, the ones are going to cancel here. Minus h squared over 2 divided by h will be minus h over 2, and as h gets closer and closer to 0, this is clearly going to get closer and closer to 0 as well. Okay, so I think, so using the small angle approximations, this one, using the small angle approximation for cos, shows that all of this will get closer and closer to 0, and all of this will get closer and closer to 1. But as I said before, you don't necessarily have to show all of this to get the 2 marks for part B.